Hey everyone, and welcome back to this class, the Numpy stack in Python. In this lecture, we are going to go more in depth about vectors and talk about matrices too. You've already seen how a NumPy array is like a vector. We can do things like add them, multiply them by a scalar, and do element-wise operations like squaring. So what is a matrix? One way to think about a matrix is that it's a two-dimensional array. Another way to think of this is that it's a list of lists. In fact, you can use a list of lists to initialize a matrix. So let's try that. So m is equal to np.array. First list contains 1, 2. The second list contains 3, 4. Notice that they have to be the same size. So the convention is that the first index is the row and the second index is the column. Let's create an actual list of lists for reference. So let's copy what we had above. There's our list of lists. So let's say we want to get an element of the matrix. Let's say we want to get the 1. With a Python list, we'd first index the row, and that would give us the first list, which contains 1, 2. So let's try that. So we have 1, 2. Now out of this list, we want the first element, so in total that's L of 0, and we get the 1. Notice that we can do the same thing with the NumPy array. So we can do M of 0, that also gives us the 1. But there's a shorthand notation which looks more like MATLAB with a comma. So we get 0, 0, that also gives us a 1. So that's convenient, it's 1 character less of typing. Note that there is an actual data type in NumPy called matrix. It's just np.matrix. So we can do that as well. We pass in the same input. We get a matrix. Now this works somewhat similarly to a NumPy array, but it's not exactly the same. Most of the time, we just use NumPy arrays, and in fact, the official documentation actually recommends against using matrix. So we won't worry about it too much in this course. If you see a matrix, it might be a good idea to convert it into an array. So you can do that using np.array, and you pass in m2. You get the same matrix, but as an array. Note that even though this is an array, we still have convenient matrix operations. So as an example, a.t gives us the transpose of A. To summarize, we've shown that a matrix is really just a two-dimensional NumPy array, and a vector is a one-dimensional NumPy array. So a matrix is actually like a two-dimensional vector. A more general way to think about this is that a matrix is a two-dimensional mathematical object that contains numbers, and a vector is a one-dimensional mathematical object that contains numbers. Sometimes you'll see vectors represented as a 2D object. For example, in a math textbook, we might say a column vector is 3 by 1 and a row vector is 1 by 3. And sometimes we might represent them like this in NumPy. But since there are 2 dimensions, that makes it more like a matrix, so it's a little confusing. When in doubt, just remember that there are 2 kinds of things we've discussed so far, 1D arrays and 2D arrays.